Alright, let's look at some other questions. Now these are more of proof related. Now these are going to help us improve our knowledge of the sine rule and the cosine rule. So let's look at these one by one. So we have small a squared minus small b squared over c squared is equal to sine capital A minus b over sine capital A plus b. So for this case, these just need you to follow the series of steps I'm actually going to show you. So let's prove from the left hand side. I always prefer proving from where we actually have the small letters towards the capital letters. That will make it so much easier. So from the left hand side, we actually have that. Now we know that from sine rule, we have small a over sine capital A is equal to lowercase b over sine capital B is equal to lowercase c over sine capital C is equal to 2r. So we know the sine rule is stated that way. Now when you cross multiply, we can actually see that small a can be stated as 2r sine capital A, small b can actually be stated as 2r sine capital B, and small Alright, so we can see that small a is equal to 2r sine capital A, small b is equal to 2r sine capital B, and small c is equal to 2r sine capital C. So substituting in those values to where we have the a, b, and c, we can actually see that this is what we have. Now we can open brackets, and then everything in brackets is squared, and that's what we end up with. Now we can factorize out 4r squared on both sides. Alright, so let's continue with that. So when we pull out 4r squared, you can see that it cancels out from the denominator and numerator. Then that's what we actually remain with. So we remain with those squares. But I can see that the values in the numerator can be expanded as that. So it's the same as sine A plus sine B is equal to sine A minus sine B. Now let's deal with the denominator. I want to make a change to that capital C, because in the final proof there is only an A and a B. So we actually have to eliminate that capital C as the next step. So we know from angles of a triangle that A plus B plus C is equal to 180 degrees. So C is equal to 180 degrees minus A plus B. So we're going to substitute that in, and that's what we actually have. So wherever there is a C, we're going to put that. So we now end up with sine of 180 minus that, and then brackets. So the squared that we have here, we're going to place it outside. Alright, so when we have that, we can actually see that we can actually expand the denominator as a compound angle, and that's what we have. Now remember that a sine of 180 is 0, and then a cos of 180 is a -1. So the -1 here will affect this to become a positive. Then we end up having a sine A plus B with the squared outside. Now we can move on to applying a factor formula to our numerator. So we're going to apply factor formula to both. So when you apply the factor formula on one of them, so this expands to that, and then this expands to that using factor formula. Now after this step, we can actually see that now the easiest thing to do here is to collect like terms. So as you can see, there is an a plus b over 2 here, then there is an a plus b over 2 here. So we're going to bring the values that have a plus b over 2 together, and the values that have a minus b over 2 together. So when we rearrange this, we actually end up with that. Now let's just reserve these 2's and keep them where they are. So we've grouped the a plus b over 2 and then the a minus b over 2. Now the reason I grouped them this way is because they remind me of a certain double angle. Do you remember that when we have sine of 2a, I believe you remember this, that sine of 2a is equal to, it's equal to 2 sine a cos a. So we're going to be making use of this knowledge. So when it comes to this double angle, we can actually say that this value is the same as this one and this one. So in this case, our items here are a plus b over 2, and here is a plus b over 2. So when you use these rules, because we're going to convert this, so we have them in this format, then we're going to convert them back into that format. So we are simplifying our equation. So we end up having this. So this value here becomes that. So it's sine 2 into this angle a plus b over 2, and then this also becomes sine 2 into a minus b over 2, and thus we've simplified it. Now we can see that the next step is this 2 can multiply in brackets even here, and then we can see that the 2's will cancel. So the 2's cancel on both sides, and this is what we end up with. Now we can see that there is the denominator and this are alike, so this cancels with one of the denominator values, because the denominator value, since it's squared, it means it's this times itself. So that's what we have. So this cancels with that, and hence we remain with that, and then hence we've proved our equation.